Okay, Cappuccino, let's see if I can explain problem 15 on chapter 1 review without taking an hour. It's kind of a complicated problem. So the first question they ask is, what is the area of this shaded region? And they tell you the radius of the circle is 15, and they tell you that this arc length is 10. So they don't say it in those words, but that's the information that they give you. They say that AO is 15, and they say arc AB is 10, and these are all centimeters. All right, so in order to find the area of this little piece out here, we don't have a formula that does that directly. So if you look in the new formula packet, here are like the area stuff, area of a sector. They have that. They have area of a triangle. They have length of an arc, but they don't have area of that, whatever that is. Okay, so we're going to have to figure it out. So from the things we have here, we can find the area of a sector. That's this little piece right here. We can find the area of a triangle, and that's this little piece right here. So, hey, we're looking pretty good. We can figure out also the area of a semicircle, and if we can get the area of the semicircle, we can then subtract the area of the triangle and the area of the sector to get the remaining area here that I highlighted in blue. Okay, so we can do this. All right, in order to find the area of this sector, area of a sector, the formula is theta, that's the angle, we'll put it right there, theta over 360 times pi r squared. Because pi r squared is the area of the whole circle, and we just have a portion of the whole circle. There's 360 degrees in a whole circle, and we just have part of it. Okay, you might notice that in the formula packet, they don't have any formulas with radians. Okay, so we're now in math applications, and for some reason, they're not so into radians. But you could also do this formula in radians. Instead of 360, it would just be 2 pi, because there's 2 pi radians in a circle, and then you could cancel out the pi's and do the rest of it. Okay, but we're going to go ahead and operate in degrees because that seems to be what math applications wants us to do at this moment. All right, so here we go. What are we trying to find? We need to find this angle in order to be able to find the area of the sector. The area of the triangle, sorry, let me just finish my thoughts here. The area of the triangle, we can do a couple things. We could do, this is the base, and we could figure out the height, and then 1/2 base times height. But we do have the area of a non-right triangle as 1/2 AB sine C. Okay, so that's also from our formula packet. This is area of a non-right triangle, 1/2 AB sine C. So we actually already know, I'm going to call this alpha right here, this angle, we'll call that alpha. We know A and B, those would be these two sides. Let's use a different color. Dun, dun, dun. That'll be this one and this one. Those would be my A and B. Those are both radii of the circle. So I can say that the area of the triangle is going to be 1/2 15 times 15 times sine of alpha. Okay. Once I figure out what theta is, I'll be able to figure out what alpha is because they have to add up to 180. All right, I also need to know the area of a semicircle. So area of a whole circle is, of course, pi r squared. So area of a, I'm just going to make a little symbol, we'll call that a semicircle, is going to be equal to pi r squared divided by 2. Okay, so that would give me the area of the whole thing, and then I would subtract off the area of the sector and the area of the triangle. All right, all of this hinges on figuring out this angle right here. And that's where this 10 is going to come in handy. We know that the arc length is equal to 10, and we have a formula for arc length. Length of an arc is this guy right here. So we're going to use that. So my arc length, which is 10, so well, let's write this down. Arc length, I'll use L for length. Arc length is equal to the angle over 360 times 2 pi r being the entire circumference. Okay, so I know the radius and I know the arc length. So the arc length is 10, theta over 360 times 2 pi, and I know the radius is 15. Okay, I need to get theta by itself, so I'm going to multiply both sides by 360 and then divide both sides by 2 pi 15. Okay, so just using a little algebra, I'm going to rearrange this. I'm going to have 360 times 10. Okay, that's moving over here, and then I'm going to divide by 2 pi 15. That gives me theta. Okay, again, this is we're supposed to be using our technology here, and I think I figured out how we can see my screen. Let's see, fingers crossed. Okay, so if I do this, oh, look at that, it's working. 360 times 10 divided by, and I'm going to put all of this into parentheses, so I divide by the whole thing, 2 pi 15, close my parentheses, and I get 38.2 if I round it off to 3 significant figures, but I'm going to, of course, keep this in my calculator for further calculations. Okay, so I get theta is equal to 38.2. And that would be degrees. We're working in degrees here, not radians for some strange reason, but we'll just go with that. Okay, so that's my theta. To get alpha, all I have to do is do 180 minus theta. So alpha is going to be equal to 180 minus theta. So let's go ahead and get that one. So 180 minus, and see, I have it in there so I can select it, and equals 141.8. So alpha is going to be 141.8 degrees. Okay, so now we're set up to do all of these areas. So first of all, I'll do area of the triangle because I have it handy right here. So this is going to be the area of this triangle. I'll go ahead and highlight it. This one right here. That is going to be this formula. Okay. So I'm going to have 1/2 15 times 15, because these are both radii, times sine, and the c here is actually the alpha, and the alpha is 141.8 degrees. Okay, so that's going to get me my area. So my area of that triangle is going to be equal to, let's put this in, 0.5 times 15 squared, because 15 times 15 is 15 squared, times sine, and notice I have that 141.8 still in my calculator, so I'm going to select it, put it in, and then hit enter, and I get 69.6 if I do 3 significant figures, 69.6, and this is area, so this is centimeters squared. Okay, so there's the triangle. Okay, let's go ahead and do the sector next. I kind of buried my sector over there. So I'm going to do this one next. The area of the sector is equal to theta over 360 times pi r squared. So we have theta, we now know, is 38.2 over 360 times pi times 15 squared. Okay, again, get out my handy dandy calculator. So this is the area of the sector. Area of the sector. So I've got my 38.2 is still in here. So I'm going to go grab it. There it is, 38.2 times pi times 15 squared, all divided by 360. And I get 75. Holy cow. That's a nice round number. 75. That's centimeters squared. All right, now I need, I've got the whole semicircle. I got to get the area of my semicircle. So the area of my semicircle is pi r squared divided by 2. I'm going to save myself some space, just do it right here to the side. So pi times 15 squared divided by 2. So pi times 15 squared divided by 2. And I get 353.42. Does that seem reasonable? Yeah, I think so. 69.75. Pi r squared divided by 2. Okay, so my area of my semicircle is equal to 300. Oops, I'm getting off the bottom of my paper here. 353 That would be 3 significant figures. But again, I'm going to keep the whole thing in my calculator. So centimeters squared. Okay, so now just that sector here, just that, sorry, I don't even know what it's called. This blue area here, just the part that we want then is going to be the sector. So our final area that we want, did they call it? What did they call it in here? Find the shaded region. Okay, so the shaded region is going to be 353 minus 75 minus 69.6. That should give us our final answer. So let's have a look. And hopefully I did everything right. Okay, so I have that in there. That minus 75 minus, where's the 69? I'm going to go back up and collect it. There it is. Enter and enter again. And I get 208.86, which rounds off to 3 significant figures, 209 centimeters squared. All right, so that's part A. Oops, sorry, there's part A. Okay, part B. Let me find my notes for part B. Part B asks for the perimeter of the shaded region. Okay, so that's not so bad. I think the area was actually harder. So the perimeter, again, let me draw the shape. Okay, we know this is 10, and that's 10 centimeters, and we know the radius is 15 centimeters, and we know this angle here, we just figured that out, that was 141.8, and we're trying to find the perimeter of this shape. So that means we need from here to here, and we need from here to here. So really not that big a deal, because we can figure out the circumference of a semicircle, circumference of a circle. So circumference of a whole circle is equal to 2 pi r. So if we just want half of the circle, I'm going to divide that by 2. And of course, my dog now wants to bark. So 2 pi r divided by 2, cross out the 2's, I'm left with pi r. That will give me the semicircle, and then I just have to subtract 10 off of it, and I will have this. So I'm going to call this x. Okay, so x is going to be equal to the semicircle, pi r, minus 10, because the 10 plus x has to equal the semicircle. All right, so x is going to be equal to pi times 15 minus 10, so I'll just do that on my calculator. And I get pi times 10, 15 minus 10 gives me 37.1. Okay, so that's equal to 37.1. So that's right here, 37.1 centimeters. Now I just need to find this side of this triangle. And we can find missing sides of triangles using the cosine rule. So here's my triangle. I'm just going to copy it down here. So this is my 141. This is my alpha, and alpha is equal to 141.8. And then these are both radii, so these are 15. So I know the angle between two sides of a triangle, so I can use the cosine rule. So I'm going to call this side, I'll call it C. So C squared is equal to A squared plus B squared minus 2AB cosine of that alpha, or cosine of big C, if we're using the formula. Okay, so my dog is whining. He wants out of my room. He's been in here with me, happy as a clam, but now he wants out. So hold on. Okay, let's go. Great, I'm back. Okay, so let's go ahead and put in our numbers. So C squared is equal to 15 squared plus 15 squared minus 2 times 15 times 15 times cosine of 141.8. And I'm just going to put that into my handy dandy calculator. So 15 squared, let's see, can we show the whole thing? 15 squared plus 15 squared minus 2 times 15 squared, because that's 15 squared, times cosine. And I wonder if I have that 141 in here still, that I can grab it. There it is. So I scrolled up, I found the 141.8, put it in, hit enter. Okay, that gets me c squared. So c squared is equal to that 803.6 business. But now I need to take the square root. So to take the square root, I can just do caret. We'll take the answer, caret 0.5. 0.5 gives me square root. Okay, so that's one way of doing it. And I get 28.3. So equals to 28.3. So remember, that was, back to my drawing, that was this right here. So this is 28.3. So now the perimeter, that's centimeters. So the perimeter of this shape is just going to be the arc length, 37.1, plus that chord going across the circle, 28.3. That's what we call a segment going across. Sorry, you can't see what I'm pointing at. This is called a chord. If it's going across a circle, but not through the center, it's called a chord. I just remembered that. Okay. All right. So let's add those together. 28.3 plus 37.1, still in here, and add them together, and I get 65.5. And hopefully that is the same as the answer in the back of the book. I've been finding a lot of errors in this book. I talked to the publisher, and they gave me a list of corrections to the errors, and there's a long list. So I will try and keep you apprised of when something is an error when I assign a problem from this book, because there seems to be quite a few mistakes. All right, so that was problem 15, A and B. This was part B. Bam. And moving on.